Welcome back to the main room, everybody. It is time. This is your time. It is the wrap up. I hope that every teacher has their cameras ready to share, have a group to share. We will spotlight your team so they can come and share with us and the entire team. But Carla is going to start us off with a wrap up. And I think I saw a Slido in there, Carla. Is that right?
Yeah,
All
yeah,
right.
we have a little Slido. It's been so much fun, all of you sharing while we've been going through. So while we've been in design and testing mode, right? This is all part of our engineering process, but we are now getting to like the ready presentation mode of we finished our designs and now we're going to be ready to share. And here's what's really fun, right? When we are doing our design sharing, we don't want to just focus, yeah, we want to celebrate what went right, but we also want to hear from you what went wrong during the process and what adjustments that you had to make, because we saw so much of that learning happening, because that is where the learning happens, is with our failures. So yeah, we're going to pop on. We'll just do a real quick Slido. Oh my gosh, I'm clicking the buttons too fast. So pop onto Slido and this is always really fun. And I promise you, this is anonymous, so you don't have to worry about your teachers seeing what you're saying, what your favorite subject is. But what subjects do you love? What subjects do you love in class? Which ones do you get the most excited about? This is always a lot of
I
fun.
see one person is
Yeah.
typing. Please use that QR code, grab your phones. I know you might not have a device in front of you to log in at slido.com, but that QR code is super helpful. Oh, I see Patterson Steam. It has a couple of cell phones up. Here we
Good
go.
job.
Oh,
Phys ed's getting up there. English. This is always so interesting to me to see how these subjects get to rank out for everybody. English up there. Math is up there. Phys ed. I mean, who doesn't love phys ed? That's English. Chemistry. Where's all our chemists in the group? Got quite a few votes. And this is a really interesting distribution. We see a lot of people with English at the top. That's great. I'll give you another 20 seconds for the last few people to put their votes in. And I'm going to tell you guys why I love to do this little discussion, is because sometimes when we go into engineering classes, especially into our STEM kind of classes, we can maybe be pigeonholed thinking that, okay, I need to have math and I need to have my physics, and that's going to be the most important subjects that when I get it, if I'm thinking about engineering. And here's the thing, is that all of these subjects, remember we talked about in the introduction, engineering is about solving problems, and problems exist all around us in all different areas. And so really in engineering, we end up having to use all of these subjects. And I loved Grace when she was talking about in her discussion, she talked about how important the technical writing and being able to present. So somebody might not think, oh, English, that's not an important subject for engineers. It really is. We need to be able to technically communicate. When you're talking about and doing when you were working with your lab partners, you needed to be able to write down what your design was going to look like. You needed to be able to fight for your design objectives. So if you had an idea, you have to be able to communicate that well. Phys ed, just understanding movement is so important in engineering. And you'll find that, yeah, we get to take it a little bit more to the science side when we start looking at vectors and movement and dynamics. But it is, we learn a lot about just our own human kinetics in phys ed. Math, I mean, that's an obvious one. We do use a lot of math and a lot of physics, but social studies. Who would think that social studies is really important in engineering? But it is, because we are solving problems for people. So we have to understand how those people are impacted and what kind of things we have to consider when we're coming up with our design solutions. So for example, when you were doing your when you were doing your projects, you were building a house, right? So people have to come in and out of that house. If you put your solar panel right at the front where people can't get into the home, then you haven't really achieved the objective of your house being able to work for the humans that are involved. So I just love to really get people thinking about, don't predispose that only people that are really strong in engineering and math and really technical sciences are meant to be engineers. If you like to solve problems, that's what engineering is really all about. Okay, so now we're going to talk about, like, what kind of problems did you encounter? I know we saw some very common problems that different classes were having. So what kind of problems were you encountering during the lab? you know, the obvious one, getting the LED to turn on, right? So the light wouldn't glow. What other kind of problems? So we were having, I'm going to start to break these down, right? So the light wouldn't glow, and sometimes that was because of our configuration, how we were actually setting it up. Sometimes it was materials, right? One of our classes ran out of glue, and so they didn't have enough glue in the class to keep building their structures. Getting the windmill to spin constantly. So getting your wind turbine to keep spinning, that was really important to make sure that that was kind of your execution. How you executed your construction was impacting whether your turbine was able to freely flow. Some of you had materials problems, right? We had some of our jumper cables that didn't work. Like when we switched them out, it was actually a defective jumper cable. We had some solar panels that broke. So that's going to happen as well in engineering. Sometimes we have materials issues that you might go through all this troubleshooting and just find out, hey, it's broken. It just doesn't work, right? So that's what is really fun, though, is about how we did our problem solving. Like, what did you do with those problems and turn them into solutions? What did you do with those problems and turn them into learning? How many of you learned from some other class? Like maybe something happened. I can remember one of our early issues with one of our classes was that they hadn't stripped their wire, so they weren't getting a good connection between their leads and their jumper cables. And so that was, you know, probably other classes were also having that same problem, but because we were able to diagnose and troubleshoot with one class, we were able to solve that problem for multiple people. And that's what engineering is about. Okay, so you guys are having lots of this is all engineering. Everybody that's throwing up their ideas of what went wrong, that is part of the engineering process. And so that's what we want to talk about now, is we want to have some people we have some people with their cameras on already, but we want to have people come up and present their designs to us. And I want to focus on what your goals were for your design. But really, if you had a problem during it, we want to hear about that. We want to hear about what went wrong and what you had to do differently.
Carla, can I ask you to stop sharing? I think Norfolk Technical Center has a prototype on their camera. I'm hoping that somebody from this group can chat with us. Hi, can you hear us? And can you unmute so we can hear about this amazing design? Look I see 3 fans going and a really bright LED.
Wow, that's amazing. Look at, you guys must have partnered up and built use some of your lab kits together. That's amazing. So you've got your fans, or you've got your wind turbines going. Where is your solar panel? Do you have that lit up as well?
So we actually didn't use a solar panel because we couldn't get any of the sunlight from outside to charge the solar panel up. So we just used the wind.
Okay, fair enough. And I like it. Like, tell us a little bit about your design. What were you going for here?
So one is like with a bottle. I don't know if you can see it all the way.
Yeah.
If you lift it up, like it's gonna stop. But one has a bottle, and then one is like an outhouse type thing.
Okay.
And then the last one is like a shack kind of type.
Okay. So you've built a whole little village here.
Yes, ma'am. Basically, yes, we did.
That's amazing. And what are you using right now to get them to spin? Do you have a fan going?
So we actually have this handy dandy.
Perfect.
Yeah.
Okay, that's amazing. I love how you've you maximized, because you weren't getting your solar, like, so you had a limitation of your site, right? Your site limitation was you didn't have enough solar energy to capture, so you went and maximized where you had your wind. So that's amazing.
Thank you.
Thank you.
Fantastic work. Thank you for sharing.
And you've got some really cool architectural features in there, right? So you've got a couple different roof structures. You've got a shed roof. You've got a flat roof. You've gone and used a water bottle. So even incorporating some recycled materials. Wow, you guys have knocked this out of the park. Awesome.
Thank you so much.
Thank you so much. Good job.
Great job. And I think I see in Challenge Prep Academy, I think I see a project in the camera, but I'm not sure. If you want to raise your hand in Zoom, we can spotlight you when you guys are ready. Challenge Prep, are you ready or you're not ready? Not ready? Not yet? Okay.
Not yet, but we want to see you. We know that you've got it working because we saw you in the breakout. So
I see a group from Humanities 2. It looks like they're prepping. Oh, the camera just turned around. Humanities 2, are you ready for us? Let me see if this group is ready.
I'm excited to see how they problem solve with the lack of glue in this class. So
Oh my goodness. I see a lot of things moving, but I can't see a group that's ready to roll.
Anyone want to come up?
All Hallows, Marie Regina, you want to share? Patterson's team, anyone from your classrooms want to share? Don't be shy.
We're still waiting to hear back from Westwood too, because this has been our passion project the whole time.
All right. Duval High School, anybody ready to share?
You know
I think
what?
people are
Even if
getting
somebody
ready.
had one that didn't work, we're happy to hear about that too, because like I said, part of the process. Oh, here we go.
Oh,
Philadelphia
Philadelphia
Academy.
Academy. I'm going to spotlight you, Philadelphia. Thank you. Wow.
Oh, wow.
Oh, wow.
Unbelievable.
Yes. Like I said, we had a delay with supplies. We finally got them. So we
Okay.
have a few people bringing things together. I've got like 2 groups almost done. Yes, literally. No, 3 groups.
Okay.
And so that'll be the last for this room. And you should see that lighting up and spinning, I guess, within 10, 15 tops.
Oh,
And then we'll set them on a display rack with the rest of the work for the other kids in the other rooms.
Okay.
I can see the light, Carla. Can somebody tell us about their design? I know you guys had limited time apparently since you just got it. How did it work out for you?
Actually, so far, I think the turbine part was my kids got it fast. Like these groups were the first ones to get it. The issue was that when we ran out of glue in our room and a couple of other rooms, it slowed down our progress. Otherwise, we probably would have been where we're at now like an hour ago, but it's okay.
Okay, no worries. As soon as you have somebody, you let us know and we will get them up here and tell us about it. I know you
unmute and let you guys know. Not a problem.
Thank you. Okay, Philadelphia Academy.
All right.
Philadelphia Academy, you want to show us?
I think Humanities too. They just unmuted, but then some. They left the camera. Challenge Prep, are you guys ready yet? Even if you're midway, we want to hear where you're at.
I think Philadelphia Academy is different than Humanities too.
We're ready.
No, all right.
There we go.
Okay. We had to use a different solar panel because our like small one that came in the kit broke. So we have it set up on a birdhouse, and then we have our wind turbine on the side.
Okay.
And turn it on.
Yeah, so it's going to get loud with the fan, but
okay, we're ready for it. Oh, there we go. We've got some, we see some light. That's amazing. And so your solar panel is where it's on the front of your birdhouse? Good job.
Yeah.
I like how you've got it nicely placed. How did you secure it to the side of the birdhouse to get it offset so that your wind turbine would spin?
Oh, the turbine we used hot glue, and the solar panel we used zip ties.
Wow, that's a new one. We haven't seen zip ties yet. Like it. Zip ties are engineer's best friend, just FYI. That's amazing. Good job. So did you have any, so what were you had some challenges because you couldn't get your original solar panel to work?
Yeah, it kind of broke. So yeah, it broke, so we weren't able to use it.
Good job. Well, way to problem solve. Thank you for sharing. Okay, do we have anything else?
We do. We have Challenge Prep Academy says they are ready. So I'm gonna spotlight that group.
Let's do it.
There they are. Hi. Can you unmute so we can hear you all?
No, you go. No, I'm just last. Hold on, man. Go. Who wants to present first?
That because I already done.
No, I've already presented once. Okay. I'll do it.
Thank you.
Thank you. Awesome. Love the volunteer.
All right, so we weren't done yet. So we were going to put the solar panel on top of the roof right here, but like we didn't really get just finished. So we're gonna put it like right here, and then we're gonna have the turbine at the bottom, so that way the top can catch the sun, and this can catch the wind, and then if it worked out perfectly, the light can be emitted from inside the little house.
Okay. You want to get the inside, you're looking to light up inside. Okay. And
Yes,
you did have all your pieces working, right? Because I know we saw you had your wind turbine working.
yes, ma'am. Before like we have broke up, we have broke out. I managed to get the solar part working.
Okay, perfect. Now on the other desk, I see you've got a little bit of a different structure going on with your wind turbine. So you've got an independent base on there. Looks like. Want to tell us about it?
So we try like many times with the light, but it wouldn't work. But actually it did. So now we try to build a house to put the like everything on it. Like
Okay.
this, but we're not. She's doing this.
My condo. I was making a condo.
Okay. And this is also, I love this because this is actually one, like, this is an example of how you can have a material that's not very strong on its own, but depending on how you configure it. So it looks like you're rolling paper, right? Is that what you're doing?
Yes.
Yeah. So you can gain a lot of strength in paper by rolling it. And so you're the first team that I've seen, I think, that has done this. But that's a really, really cool design. I like that. And I like how you've got your wind turbine up nice and high. You get a lot of vertical there. So you're going to have that nice capture without any kind of effect on the aerodynamics. So your wind isn't going to be, it's going to have maximum flow through. So that's great. So what are you doing with the bottom, the multicolored side there? What's
Our
that going to be?
condo. That's the condo, right?
Oh, the condo. Have you thought about condo fees and what you're going to charge?
Yes.
I love it. Great design.
Thank you.
Perfect. Thanks so
Fantastic.
much.
Thank you for sharing Challenge Prep Academy. Fantastic. All right. Is there another group that's ready to share?
It looks like maybe Al Hallows. Are you ready?
I have two cameras from All Hallows. Oh, this one raised. I'm going to spotlight this group. I think
Okay.
this is a better angle. Let's see.
Okay.
Does this work, gentlemen? All right.
Okay,
Can you
let's hear
unmute
it.
so we can hear you?
Here, we can do ask to unmute too.
Can you hear us?
Yeah,
We can hear you. Yes.
Hi. We finally got the turbine working. So we decided to use we use one solar panel to get it working, but we decided to use four just to like see what happens. So we got it to work, and it was like going really fast, and and then we discovered like how it actually works. Like,
Okay, awesome.
Yeah.
So you took a couple of different lab kits and put them together?
Yeah.
And
you put them all in series, your solar panels?
as you can see.
Yeah,
so
if
we
you can
have-
see, I don't know if
Yep.
you can see very well, but use these two, and then we just like tapped in on like those other two to like make it to like increase the voltage.
Yeah. And we talked about that, right? So that's one of our limitations with solar is that we have to have multiple arrays. We need arrays of solar panels in order to get it up to enough, because we have a maximum amount that we can capture, of course, with current technology. And so putting them multiples together in series is a great way to combine them. So good job. And I like your wind turbine. You've got it up nice and high.
Yep.
And yeah, free flowing, so no obstructions, no disturbances of your wind turbine rotation. So that's amazing. And can you show us? Is it?
So we don't have enough sunlight here
Yeah,
to
that
get
was
it.
before-
Yeah, but it was before it was
yeah.
working. Yeah.
Yeah, I know exactly what you mean. I had mine working, and then the clouds came out, and then it stopped. So, yeah, perfect. Well, good job. And did you have any challenges during your process? Like, what did you kind of adjust during your design cycle?
Let's see. I was really trying to like see how just to get the turbine working was probably the biggest obstacle there is, because we got the light to shine, and we use the other polar they call that solar panels.
Polarity, you reverse the polarity?
And we got the light to actually work, but we tried to that was our biggest obstacle to like actually get this working. So so we just decided that, and probably that was the biggest one. But after we got this working, it was just easy going after that.
Yeah, we just
Yeah.
added
Okay.
more, kept going faster and faster.
Yeah.
Nice. Good job. Well, I hope that that's the important part, right? Is the learning, the pieces when it doesn't work and then you fix it. That's where the real learning happens. That's where the engineering is happening. So good job. Thank you.
Fantastic
Okay,
job,
Monica,
gentlemen.
do we have
Thank you.
anyone else?
I don't have any other group ready right at this moment. I'm trying to see if Maria Regina or if Patterson wants to share. Duval, do you have somebody that wants to share? I see Maria Regina coming to the camera. Yes, are we ready to share it at Maria Regina? Yes? Okay, I'm gonna spotlight you, Maria Regina. Hi, ladies.
Hi, we just lost some students for lunch. That's why a lot of them are here.
Yeah, we've seen a couple of great projects from your class. Does anybody want to come up that we haven't seen already, or even one of the ones that we have seen, if they want to kind of come represent?
I haven't seen any from this group. Please
Oh,
come up and
yeah.
show me.
They had lots of success in this class.
So this is one group. They went to lunch, but their solar panel was able to work, but their light goes off and on. So some of the challenges were to keep the solar panel working and the connection working right.
Okay, your connections were a little funky.
Yes.
Yeah. Okay, that's great. And that one did not have a wind turbine on theirs, right?
No, it
Okay.
never really worked for them. It didn't. The light didn't turn on for them, even
Okay.
though they tried several times.
Okay.
Same thing here. Yeah. One was able to work with wind, but they didn't put the solar panel on.
Okay, perfect. And I can't remember if we checked, did you guys strip the wires, like making sure the wires fit at the end? Okay, they were all good.
Yeah.
So it's just, yeah.
Good.
All right, perfect. Amazing. Thank you guys.
Thank you for sharing. All right. And I see some in a hallway. I think it's on the floor at Patterson's team. I see some prototypes. I'm going to spotlight them, but I don't know if there's somebody there to chat with us about it. Look at those.
Awesome.
Check
Wow.
these out. Is there somebody at Patterson's team that will chat with us and unmute? Talk to us about these. Look at them all going.
I like it. I see a lot of different features. A lot of really cool architectural thought has gone into these ones.
Oh, I think somebody unmuted, but I can't see who it is. Yes, Betsy said it's a windmill farm.
So yeah, we're oh, okay. Can you hear?
We can hear you.
Can you hear me?
We can hear you. Yes.
Hello? You can hear me? Yeah. All right. Well, we have some technical quirks here. So yeah, we have a bunch of groups that kind of have things done. We're in a room right now that the sun is just past the window, so we needed the sun to come a little bit more, and then as the day went on, the sun got further and further away. So when we first got here, we had sun, and then poof, it was gone. So we had a kit from the cars. So we had those battery packs from the cars. So I went and I got those, and we talked about how it doesn't go from the solar panel straight to the outlet. It goes to the solar panels to the batteries. So we're not exactly cheating, but we are skipping that one component. So it's our battery powered village family.
But I love how they troubleshoot, right? And went with our electric vehicle kits and got some power for that windmill farm. That's awesome.
Hello, hi. So, not to interrupt, but we have one done and we've got 3 more coming. So this is our structure. So this is our structure, and it will rotate. The turbine will work perfectly. The only problem was we ran into cloudy skies. So that's why we couldn't get the video for you.
Okay.
But this one also works. The light is on right now. It's kind of hard to get the camera in there. So if you see, you can see the bulb is actually on.
Okay, yeah.
Mm-hmm. So we have full electricity and turbine power achieved. So this is project 1 from 206B. And we're awaiting, I think, 3 others. So keep working. What you doing? You ain't a boss. So anyway, the factory process continues. So we will get back with you again in another 5 to 7 minutes. Yes?
All right.
Okay. Thank you.
All
okay.
right. Thank you so much.
Thanks for sharing humanities too. Love that. I think we have about 5 minutes left, Carla. I don't know if you want to switch back to your slide.
Let's do that, because we just have a few more things, even though this is the exciting part, hearing from the students, right?
Yes,
so
it is.
Yeah. So remember guys, what we went through when we talked about that design cycle, right? We went through the design, you planned out what you were going to do, what you were hoping to achieve. You tested out the components, you built it. Some of you had problems. Quite a few of you had problems. And then we had to problem solve. We had to make the changes and go back through that loop and go back through that loop. And even ones at the end that we had them working, as a good engineer, I was challenging people saying, how could you make it better now? Right? Because these projects really never hit an endpoint. There's always a way for us to improve them. And we're seeing that a lot right now in the world of renewable energy, because yeah, we have solar panels, but guess what? If we want to make these available to everybody worldwide, we have to do a lot of improvements on the materials and the availability and how we can store power from them. So there's always, like, we never really hit an endpoint. We're always looking to try and make things a little bit better. But one of the things we love for our students to come out of these labs with is understanding kind of some of the options for when they, like what kind of pathways, what other things. So maybe you're thinking, yeah, I absolutely want to do what Grace and Brianna did and go that engineering diploma route, or sorry, the engineering degree route. But what other options do you have available to you? We have lots of cool programs. There's technician programs, certificate programs. These kind of programs are a really great way to even be an entry into engineering as well. You can go and get a real hands-on knowledge and learn about a lot more of how equipment works and different areas to work on renewable energy. And you can always keep doing that, or you can go back and decide at that point that you want to go get your engineering degree. And once you have your engineering degree, it doesn't have to stop there. So just like myself, I got my engineering degree in environmental engineering and then decided I wanted to specialize. So a lot of people will end up going back to school into graduate school and kind of continuing that down. So this chart is, we really like to emphasize that there's lots of different ways for you to be involved in renewable energy that doesn't necessarily be just an engineering degree. And I know when Brianna was talking earlier, she mentioned this slide. So the best way for you to figure out what areas you would like to work on, because remember I talked about my background, I love the environment, so I found a discipline of engineering that I was able to specialize and be able to work in my passion, right? I love working on outside and working in the environment. But if you put me in a room where all I was doing was computer programming all day, that would be horrible for me. That wouldn't be my jam. And so what you have to do is figure out what things are you passionate about, where would you love to spend your days, and figure out what kind of problems exist in that world. Like, how can you make this different? How can you help solve problems? And a lot of these associations that are up here right now, like Brianna talked about, there's opportunities out there. Right? You don't want to go a whole 5-year degree program and find out that it isn't what you want to do. So use whatever opportunities, whatever resources you have available to you to really learn, and go on YouTube. Go to YouTube and say, like, what kind of careers exist in renewable energy? What does an environmental engineer, what does a mechanical engineer in renewable energy do? And learn as much as you can to help you refine that pathway. Okay. And I like to celebrate. You guys are engineers. You just went through an engineering design process. You have found out the conceptual basics of renewable and wind energy power. You've worked on solar panels, and now you've understood how to convert them and some of the things you have to consider, like your angle. And we've been even hearing about some of our groups that switched from renewable to non-renewable, right? Some people pulled out those batteries, and so they switched over to non-renewable. So we've seen some of the limitations of renewable energy, which is it may not always be available.
Hey, Carla, I think you met that Humanities 2 group. Are you guys ready to reshare? I'm sorry, I saw them move their camera, but now I don't see them. Is that group ready? Oh, they're moving their desk. I think they're prepping the work table. Oh, I'm sorry, Carla. I thought they were ready to roll.
I know that they still had a couple classes ready, or a couple groups left. Oh, 2 minutes or 2 seconds?
Oh, we have about a minute left before we're going to get into our keynote. So if you can hop in, that would be great. And I see Milton has turned on his camera. Welcome, Milton. I know you got to see some of these groups in our breakout sessions.
Outstanding. Outstanding. Are we ready to do this? Or are we going to bring in another group?
I think they said 2 minutes, but I think our keynote speaker is here.
All right.
Alex is here.
Well, let's do it. This was an outstanding session. You all just did a great job. The designs were thorough. The architectural aesthetic appeal, outstanding. I have to give a big shout out to one, always got to shout out Monica, but I gotta also give a big shout out to Carla. Great job. Great job, Grace. Great job, Brianna. You all, you nailed it. You nailed it. We're doing this. I mean, look at some of these awesome designs. Look at the engineering and work. Oh, look at that architecture, Carla. That's beautiful. I can tell that you had your hands on this. And then look, the purple light. I mean, we're just getting, we're just going outside of the box with the purple light. Light. Shout out to Philadelphia Academy and All Hollows. They put multiple solar panels together. I love that. We got a little parallel and series circuits going on. Great engineering there. And then finally, having fun with Humanities High School. You all had great engagement. All the mentors, the staff in the background, just really making all of this happen. Shout out to the entire ET staff and team, man. Just nailed it. I really loved Maria, Regina. They've been with us all day long and just showcasing all day long, different classes, great skills. So Westwood, they were in there to win it, right? They just kept trying. You just kept trying, and that's what engineering is about. You just to keep trying to never give up. And then my home close to me, Bladensburg High School and Challenge Prep Academy. Great job. Well, I have the pleasure of introducing a very outstanding speaker today. Very good to have her. I mean, just her path and rise to success has been awesome. Alex Coleman is the head of Centrica Business Solutions from North America. She's received a bachelor's in civil engineering and an MBA in finance. That's right. She has the money right. And I don't know, I didn't even know that about you, Alex. And don't let her finance background fool you. She has a lot of experience in engineering. She has experience as a project engineer, as a field engineer, as a concrete engineer. And even prior to leading Centrica, she served as a VP for General Electric Energy and the Director of Finance for GE Power. So without further ado, I want to introduce Alex Coleman. I think most important, she's an ET board. She's on the ET board, so we love her for that. Thank you so much, Alex.
Oh, thank you, Milton. Can everybody hear me okay?
Yes, we can.
Okay, cool. Let me share my screen. One participant can share at a time. So are you sharing still or?
I'm not sharing.
Okay.
Let's see.
Let's see, share screen. Got it. I'm on it. Okay. Let me know if you can see it.
Yes, we can. Looks great.
Okay, awesome. Well, I am so glad to be here today. Thanks so much for having me. It is my absolute favorite thing to do, to interact with students and to talk about engineering and how impactful engineering was to my career and how I spend most of my waking hours. So with that, we'll kind of kick off. I wanted to tell you two things. First is you can feel free to ask me questions. And what I'm going to do is I'm also going to answer questions that you all asked at the beginning. Before I created the presentation, I got a couple of questions from you all. And in these blue bubbles, I am writing those questions down and then going to answer them as we kind of get through some of this content. But in the meantime, if you have more questions, feel free to ask them. And then Milton, I'll ask you to just, shout out if you see something that's relevant, as we're going through. So the first question I got was, what's the source of funding for the materials that are provided here today? And as a board member, I can tell you that it is really because of our corporate sponsors and our founder, who are donors to Engineering Tomorrow. We are a 501c3 nonprofit organization. That is how all of these materials are provided to you and your schools at no cost. We are always looking for corporate sponsors. And so therefore, if you happen to know anybody who would be interested in partnering with us, you can send them my way or to any Engineering Tomorrow coordinators. Make sure you tell your parents and folks at home how much you enjoyed the lab today and see if we can get them involved. Okay, moving on. So how did I become an engineer? I became an engineer really because I was curious and passionate about the environment and sustainability and conservationism. And when I was in high school, you know, in your shoes, one of the ways that I thought I would pursue that passion through my career was through marine biology. And so I got a little curious about that, started to pull that thread, and spent my one summer during high school. I took a marine biology class. And when I took that class, I realized very quickly that you had to be really good at memorization to be in biology. And I happen to be terrible at memorization. So that was not the degree for me. And I was back to the drawing board. And I was a little frustrated talking to my chemistry teacher about this. I was good at chemistry and I connected with my teacher, and I was telling him about how I actually didn't want to be a marine biologist in the end. And he said, well, what about engineering? And I said, I don't know, maybe I'll go into environmental studies. And he said, you know, an engineering degree will allow you a lot more flexibility throughout your career. And so I started to look around different colleges that had environmental engineering. Right now, if you were going to go and search for this degree, you would find many programs across the country and world for environmental engineering. At the time that I was pursuing environmental engineering, it was usually connected with civil engineering, and it was mostly focused, at least at Bucknell, on wastewater treatment plants and landfills. Unfortunately, I didn't realize that until I got to Bucknell and was in the major, that I realized that environmental engineering wasn't necessarily solar and wind, et cetera, that I thought it was at the time, but was instead landfills and wastewater treatment plants, which are very important parts of our society, just not really what was interesting to me. I was really interested in solar and whatnot. But solar was really it wasn't a new technology. The technology has been around a long time, but at this time, when I was going to college, it was just really starting to become very commercialized and mainstream. So it didn't make its way into college curriculum for a few more years. So anyway, I stuck with my major at Bucknell and I used internships. I heard Carla mention internships as such an important way to explore and figure out what you want to do with your career and where you might want to end up. I did the same. You know, I am located in New York City, and I was curious about financial services because that's what is a really huge part of the economy here in New York City. So I did want to take some time to explore that as a potential career path as well. So my first internship was in the financial district in New York. And my next one was much more focused on the major that I was majoring in, which was civil engineering. And I worked for a construction company out in the field, building a railroad station in Newark, New Jersey. That was my internship. Bucknell. And I liked it. I liked being out in the field. I liked being with people. I liked actually seeing something go in the ground, like steel go in the ground. That was great. I didn't particularly enjoy sitting behind a computer all day. And so this was really for me. So my first job out of college was to work for Keynote, which is a large construction company here in the United States. And I was put on a bridge project. And that bridge connects Harlem to the Bronx in New York. And this is a picture of it, a part of it anyway, floating down the Hudson River. Actually, I think at this point it's floating back up the East River. But what the bridge was it was a kind of low bridge close to the water, because high bridges that allow freighters to kind of go underneath the bridge so that the bridge doesn't have to move, like a lift bridge or a drawbridge, they require really long on-ramps. And if anybody's been to a city or lives in New York knows that real estate is not that easy to come by. And there's not a lot of room for a humongous on-ramp. So on the east side of New York especially, there are a lot of movable bridges. So the lift bridges, the drawbridges, and this one was a rotating bridge. And so this was, or what we call a swing bridge. And so this was the swing span. There wasn't even enough room to build it in Harlem or the Bronx. So we instead built it in Albany. And then we put it on 2 barges, which we welded together, and we floated it down the river, down to New York City. So this is a picture of it floating into place. Now, my job on that project was, as Milton said earlier, I was a concrete engineer on that project, responsible for all the concrete poured. I was responsible for some of the piers that the steel sits on that then people drive over now. And so as we were floating this bridge into place, the number one question was, is it going to fit? Did we build it right? And we did. And it was a very exciting and fun project. But you might be thinking, hey, wait a minute, I'm not in the bridges lab. Why is she talking about bridges? Well, I did, kind of spend 3 years at Keynote, and kind of in my 3rd year was really charting my plan to get back into that more renewable energy track that was calling me as a passion and somewhere where I wanted to spend my time of my career. So I went back to get a graduate degree, and that was a master's degree in business administration, MBA, or what a lot of people call business school. So that was 2 years, and in that time, I spent as much time as I could just learning as much about the energy industry as I could. And one of the ways that I did that was by becoming president of the Energy Club. First I joined the club, and then I became president of the club, and that allowed me to network with a lot of people and really just get curious and understand what people were working on. And I have a secret to share with you all. You are students right now. This is a great time to ask for help and pick up the phone and call people to ask, just get curious and say, hey, do you think you could let me shadow you for a day? Could you tell me about your job? People are really likely to pick up the phone if they know that you just are looking to learn and you're a student. Somebody had shared that with me when I was in business school, and I really appreciated that advice. So I want to share it with you as well. So after learning as much as I could about business, about finance, and then of course about the energy industry, I ended up at General Electric, or what most people call GE. And GE, I was in the wind turbine manufacturing division. And I was in a leadership program there, which was a rotational program where you get to kind of go around different parts of the business and spend 6 months in each part of the business and learn something about that part of the business. So the first area that I was in was in product development. And so I was responsible for really understanding which markets we were trying to sell wind turbines into and what those markets really needed from a wind turbine. So for example, in Europe, there is not nearly as much land as there is here in the United States. And so wind turbines in Europe are much closer to people's homes typically and farms. They're also need to be much bigger because they're just looking for more energy out of that very small land parcel. Conversely, here in the United States, you'll see wind farms across massive swaths of land. I'm sure some of you are in areas like that in the country's grain belt, what we would call the wind belt, and where you have massive amount of land that you can put very efficient smaller turbines in. You don't need the really large turbines. You can build farms more efficiently that way. So I was really responsible for understanding, okay, in France, they really care about noisy wind turbines. And here in the US, maybe we don't care so much. The cows, they're not complaining about the noise, right? So understanding those market dynamics and then feeding that feedback into our engineering team and ensuring that our product met the requirements of that market. And the next rotation I had was I was responsible for servicing wind turbines. So like a car, some of your, maybe you have a car at home or your parents have a car, you typically need to get your engine service, mechanical, at least if it's on an electric vehicle, you need to get your oil changed, etc. And Wind turbines, very, very similar. Got to change the oil, got to get up there. You got to get up into this, what they call a nacelle, the top of the turbine, and you go and you ensure that everything's working appropriately. So those were two of my rotations at GE. When I was in the product development area, one of the things that I learned was that people were not only buying GE turbines because they were the appropriate level of noise, they produced the right amount of energy, they were cost effective, but actually because we had a division that financed those turbines. So very efficiently, we're able to help people who wanted to build wind farms, which can cost 100 million, 500 million, $1 billion. You can really run into some capital constraints. Need somebody to help write you that check to build that farm. And GE was willing to do that to take advantage of some of the tax credits available to these projects as well. And so I went to a division of GE called GE Capital, and then I financed a bunch of projects that had GE wind turbines in them. And there I was also exposed to solar projects, hydro, geothermal, many different renewable energy types. So you can see that your career can kind of take you in a lot of different places based on what you're learning on the ground as you kind of maneuver through life in your career. One of the things that started to interest me as I was learning more about just how these wind turbines essentially plug into the grid is our transmission and distribution system. And so when you think about renewable energy or energy generally, when you turn on the lights, those electrons are coming from somewhere. They're typically coming from a utility scale plant, so like a big wind farm, and they are riding on this highway, right? This transmission highway here, which is called our transmission system. And then what they do is they kind of go into what we call the distribution system. And the distribution system is more like what you would see at your house, maybe, or what, you know, kind of going down the street, you might see poles and wires, right? Telephone pole, typically what we call it, but it usually has power lines on it too. And they then actually will connect right to your house. So unless you live in a city where those are underground, you may actually look out the window tonight and see if you can see where you get your electricity from, which is probably from a pole outside your house. And that's the distribution system. And so I started to get pretty interested in what it would look like for us to produce energy at the distribution level, right? Put solar on top of our rooftops, etc., instead of at the utility scale level, which is kind of behind the transmission line. And that's when I left to go to Centrica, where I am today. And Centrica is a UK-based utility energy services company. We, in North America, we develop on-site energy solutions for large energy users. So large buildings, manufacturers, municipalities, hospitals, schools. The school buildings that you're in are prime customer types for us. And what we're doing is we're helping to put energy efficient technology into the building so that you're using less electrons, and helping to put on-site solar, battery, electric vehicle charging stations, whatever type of energy infrastructure a customer might need that would benefit from what we have to offer to them. And what's pretty interesting about this solution is that it's all about efficiency first, right? The cleanest electron, we're here learning about renewable energy, is the one that is never used, right? And so it is important to think about that. The other thing that I wanted to talk about, which will kind of help us think through this one, is, you know, how can you all, if you're not around renewable energy all the time, think about how you use energy? And I think efficiency is probably the best way to think about that. You know, what is it that you can do to reduce your consumption, right? Just having in mind that when you turn on the light switch, it's coming from somewhere. It comes at a cost, right? And when you plug something into the wall, that comes at a cost. When you run your dishwasher or your washing machine, that comes at a cost. And if you use it at the wrong time of day when everybody else is also trying to use it, right, that's going to create spikes on the grid. That requires us to use some power that is likely dirtier because it's not coming it's coming from like a combined cycle gas turbine as an example, or natural gas. We're burning the gas to get that, to meet that peak requirement. So look around. You will see our energy infrastructure no matter where you are. You will see it. That's my answer for that question. Okay, so solar and battery storage. Couple of things. First of all, this is just a classic example of what we install on site for a customer. This is a very classic. This is somebody's rooftop, okay? And you can see there's solar on top of the roof. You can see that there are holes here that allow for certain, drainage or other parts, equipment up on the rooftop that needs some space here, right? And then this is a storage facility here. This is just in all these different boxes. There's batteries here. Those batteries are basically the same exact batteries that are on your phone, okay? And they're just really, really big. And what is happening is similar to your phone, which you charge maybe at night and then you use during the day. It's not plugged into the wall. You've got a battery in there, right? Similarly, what's happening here is the sun shines during the day, right? This is not a difficult concept, and it doesn't shine at night, right? And so you may need to be using power at night, right? And so what do? You store it in the battery. Right? Or even on a day where maybe the sun isn't shining, or maybe in the afternoon, right? When it's not shining as much. And so there are a couple of questions that you all had around this. First is, what's the smallest system that can be used to make a difference, right? For a household or a community. I mean, the smallest system, one of the smallest systems I see that really can make a difference is people have solar panels on their backpacks. You ever see this? There's like some little solar panels on their backpacks, connects to a battery. And when you're walking around outside, that charges up. And when you need to charge your phone, you plug it into your battery, which is in your backpack, right? And you're not using the grid because you're not plugging into the wall, right? Kind of that's the smallest system size I can come up with for you guys. The next is, can we potentially use solar panels for all of our schools' energy needs? The answer is absolutely, but you might need a battery to help out with those days when the sun isn't shining, or when you just don't have peak production, isn't matching exactly what the load requirements are at your facility. The next question is there a way to combine solar and wind energy? And there absolutely is. So in the end, on that transmission line, there are wind electrons, there are solar produced electrons, there's coal, there's nuclear, there's natural gas, right? Hydro, everything's kind of coming into that one transmission system, and then it's going out to the grid, right? And what some people do is they specifically pair wind and solar. When they're buying electrons, they actually choose to buy from wind and solar facilities because they do pair actually quite nicely, because wind tends to blow a lot at night and the sun shines during the day. So it actually is a very effective way to pair energy when you're procuring it or buying it. The next is, how can we use this knowledge to help our community in an everyday type situation? And I think I answered this one already. Really is just ensuring that you're really thinking about what you're using and what you're not, but also you all have a voice. And the school superintendent, they might come to visit you, and you might have the opportunity walking into school to shake the school superintendent's hand, or a local politician might come to your school and to ask them, hey, have we thought about putting solar on our rooftop? Is a question that would really make them stop and think and would give you an answer. And that's something that you all have the power with your voice to ask those questions and make a difference. So I want to stop and talk a little bit about just current events and natural gas and hydrogen, because it's something that's pretty interesting to Centrica. And I wanted to kind of address the question that was also posed here about how do we balance the cost versus the environmental impact. And so let's just take a step back. You might have studied a little bit about the Clean Air Act and the smog issues in the 1950s in the United Kingdom. If you didn't, right, what happened there was they basically couldn't see in front of them. They had such terrible smog issues. And what this was caused by coal-fired electricity production and also diesel-fired buses. And what was happening was what the British government decided to do was to switch over from coal to natural gas, which was a cleaner burning fuel source. So they switched a lot of their infrastructure, both at the grid level to produce electricity with natural gas, but also to put in different kind of devices in their homes, like gas burning stoves, as an example, right? They basically switched over their entire infrastructure via the Clean Air Act to bring in natural gas. Now, that made their air so much cleaner. Now we're sitting here saying, well, natural gas isn't clean enough, right? And so let's look at renewable energy. And now we're starting to look at renewable energy and we're saying, gosh, that's using, those batteries are using a lot of minerals and rare earth materials, right? And so now this is causing an issue. So it's a little bit like whack-a-mole, where you're always looking for a cleaner solution. But in engineering, that's what you're always doing. You're always looking to get better, right? You're always looking to improve the system and to make things better and striving for more. And so in that regard, I thought I'd just share with you, a little bit about economics, the global political landscape, how it impacts Centrica. So Centrica, the company I work for, UK-based firm, we sell gas to large homes and also large energy users. And so we have a gas storage facility, which we call RUF. That's what you see here. And that storage facility, essentially what we do is we buy gas when it's cheap and we sell it when it's not, right? So we buy low, sell high. That's the name of the game almost always, right? And so what we've saw, right, with the kind of Russian-Ukraine conflict, is that natural gas prices got very, very high because the availability of natural gas became very, very difficult, given the fact that people were trying to get off of Russian gas. And what that resulted in was very high gas prices. But we just talked about how the fact that in the United Kingdom, mostly everybody's relying on natural gas to make their homes run and their businesses run. And so that was a problem for people in Britain. And so what it would just made their prices super astronomically high, right? Because the prices were high. So this was a very useful facility where we were able to then help to reduce the cost of gas for the people of Britain. But furthermore, now that we're talking about hydrogen, there's a realization that Britain's system is very, very ripe for hydrogen introduction because it's a gas-based system already, right? And so what we're looking to do is to start to explore whether or not we can store hydrogen at RUF and instead of natural gas. And that will make it the storage facility of the future. So again, always looking to improve and always looking to balance that cost versus environmental impact. Although as we learn more, of course, the dynamics tend to change. So getting into kind of the local landscape here in the United States, there are a lot of incentives available to renewable energy to spur both development, just the development of renewable energy plants like solar or wind farms, putting solar on people's rooftops, batteries on people's homes, electric vehicles, etc. But there's also quite a bit of incentives as it relates to also socioeconomics and the fact that there are a lot of communities that were very coal dependent communities. There were coal mines in those communities, there were coal plants in those communities, those created jobs, etc., where there is an attempt to really ensure that we're able to provide investment into those communities as well with this shift in our energy use in our country. So there are a couple of questions that are actually very relevant to this. First being, we would like to have solar panels, but we rent. What can we do instead? So there are these programs called community solar. And essentially what it is it's maybe at your, you either rent or there's no room on your roof. You have a, you live in a large building. You can't really control what goes on the roof, right? But you still want to buy solar. And what you can do is you can actually kind of subscribe to buy electrons from the solar farm, which is a community solar farm, instead of buying from the traditional grid when you just turn on your lights and it's just from whatever the utility happens to be producing at that time. Similarly, this could be a very good opportunity for folks who are low-income communities because they're incentivized to reduce the cost to low-income communities. But the other thing is, given back to kind of the Russia-Ukraine conflict, that increase in natural gas pricing. We still, in this country, a lot of our electricity production is from natural gas. So when natural gas increases, our electricity prices also increase. And so this is a way of protecting yourself from the kind of spikes in certain commodity inputs into our system, such as natural gas. So this could be a way for people to actually protect themselves from that inflationary environment. The way that we like to talk to customers about energy usage is really the first step being to reduce their energy usage. That cleanest electron is the one never used, right? The next one is then convert your energy usage, try to produce energy on site, and then finally enhance the energy that you are buying from the grid. Is there a way to change the time of day that you're using energy such that you're not buying energy at the peak prices when everybody else is trying to buy energy? And the really interesting thing is these technologies that are now very readily available are also can be deployed at zero cost. So your school could end up with solar on its roof and not pay a cent more. They don't have to increase their budget, right? And the reason is because it actually provides savings because they're buying less kilowatt hours from the grid, right? And they're using what they're producing. And there are plenty of firms out there that are eager to finance these projects so that there's no money upfront required. The question, what would it take to get everyone to use renewable energy, is an interesting question because I think it would also require us to have enough renewable energy so that everybody could use it. So it's a little bit of, well, first we have to have people who want to use it and put it at their facilities, but then there's also just needs to be enough of it. And given the fact that it is an intermittent resource, it is best paired with technologies such as battery storage or other technologies that can act very quickly, and so that when the grid is strained, where everybody's trying to use as much energy as they can in a blackout environment, where everybody's got their AC blasting because it's 110 degrees, right? That's a day where the grid is strained. Everybody's trying to use the same resources, right? And so it is one of those things where we need to really be mindful about what we're using. We need to have technologies that are more efficient on every angle, and ultimately have enough resources so that we can meet the demands of the grid. So finally, what does my day look like? What is my job? What do I do? So I kind of manage the operation that I described to you, where people are, going and finding customers who need our solutions, and then engineering those solutions, and then ultimately building those solutions for our customers, right? And so on the day-to-day, I do a lot of different things. I work with human resources to make sure we're hiring the right people to get the job done that we need to get done. I'm looking at policy. I'm understanding, well, what is the latest incentive that the federal government or the local government is deciding to put their weight behind and their money behind so that we can help our customers access those dollars so they can get these projects installed at their facilities cost-free, right? Looking at kind of the external landscape and marketing, right? Well, how do we build our brand such that customers trust us, that they want to have us develop that project instead of a competitor? Looking at strategy, where do we want to play and why? Where are the right types of customers for our technical solutions? Why would we want to play there? Is there talent there that we want to be able to play into that region? The next is energy trading and wholesale operations. So that's really about that power pricing dynamic, right, that we were talking about earlier, and ensuring that we understand, well, what is the power pricing? What are the elements that are driving that price to a certain mark? And what will we do if it gets to another price, right, higher or lower? Product development, I mentioned that one earlier. What types of products and services should we be offering to customers to help them meet their energy challenges? Technology and software development. How does a customer want to interact with that solar facility once it's up on top of their roof? Do they want to see on a daily basis, on a minute by minute basis, what is the solar being produced? How can they use it in the classroom with you all, right? How can they develop curriculum around that, etc.? The reason why I put this slide on here is because you could take a class in college, you could even major in college at one of these bullet points, right? And I did not major in any of these bullet points, right? And I'm still here. This is my everyday job, right? And the reason is because I kind of had that foundational set of engineering curriculum where I was able to learn how to be a problem solver. I was able to learn how to work with a team and how to ultimately, solve problems that were important to me, that I want to spend my life solving. And so I definitely gave you a sense for what my day-to-day is like. I think I told you about the most rewarding part of my job, which is the fact that I get to spend my time solving a critical challenge that I find to be important to humanity. And I am very, very, very fortunate to be able to do that. And the career options in this field specifically are limitless, truly, truly limitless. As I mentioned, the technologies when I was in college that were part of the major versus what they are today, we wouldn't have predicted necessarily already. And I'm not that old, right? And so it's a really interesting, fun part of the industry to be in. But the cool thing about the energy industry is you will always learn. I have learned so many different facets, from a wind turbine specifically and how it works, to energy markets and pricing and trading, to the distribution system, the transmission and distribution system, and how the grid works, right? Down to how a facility uses energy and how we can make those facilities more efficient. Down to how electric vehicles and logistics, and how Amazon gets a package from their distribution center to your home, and what that would look like to electrify. I mean, there are just so many different things to learn in this industry, and I have no idea where I will be in 20 years and what I will have learned, but I am really excited to be on the ride. And I hope that, some of you might choose to join me in this industry. So with that, I'll see if there are any other questions.
That was absolutely outstanding, Alex. Really, really appreciate it. I learned so many new things about you and what you do. You nailed all the questions. You just You knocked them out. I have a couple more if you don't mind. I'll go through just two. If you unshare your screen, I will share my screen. And if this first question really is just going to be about your career, you when I look at your career, you have just really, really taken off. Like what was the key to everything? Like what was the key to your rise to success? You're killing it. What did it for you?
You know, uh, it's I am somebody who really enjoys extracurricular activities. I enjoy learning new things. I enjoy taking on more tasks than given to me. So when I was in the construction industry, my first job, I was actually in the job site trailer crunching numbers. I wasn't given a job to be out in the field pouring concrete. I had to go ask for that job. And the way I did that was I spent 4 days of the week, if it's a 5-day work week, I spent 4 days doing my day job. And then on the 5th day, I would go out in the field and I would just learn and observe and try to absorb as much as I could. When I was in business school, I went to school full time and then I started working full time. And I did that to just learn in the energy industry as much as I possibly could while I was there.
I'm hearing that theme of learning.
Yeah,
I'm catching that.
And being curious.
Okay. Last one. How do you balance it all? You just talked a little bit about what you enjoy. How do you juggle all the different things you have your hands on?
Yeah, I'm glad somebody asked this, or many of you asked this, because I didn't mention, but I always like to mention that I have 2 children and a husband, and they're little, they're 3 and 6 years old. So, I definitely have my hands full, but I mentioned that really to make sure that everybody knows that you can definitely do it all. You might not be able to do it all at once, but you can definitely do it. And what I find being very helpful is to just be very present and to make sure I plan my day and I spend my time very wisely. So when I choose a hobby, I make sure it fills one of the buckets that I want to fill. Maybe I'm, playing a sport with some friends so that I'm filling 2 buckets. I'm getting some exercise and I'm socializing, and I'm also learning something new. Right. And so in that regard, just really being very, very specific about using time wisely.
Wow, that's so great. I won't keep you. This was an outstanding presentation. Look at the play on empowerment because you're in the renewables field. But here's some notes that I took from what you talked about. You have a voice. That was powerful. You all have a voice. You have a voice in your renewable energy system community. You have a voice in general. I loved how you talked about internships being a great way to not just a pathway to success, but a way to explore. Don't be afraid to ask for help. Continue to be a student, never stop learning. And efficiency, the cleanest electron is the one never used. Outstanding presentation. Can we give it up one more time for the awesome Alex Coleman? Thank you so much for spending this time with us today. We really appreciate it.
Well, I'm going to hop in and say thank you to Alex and to Milton and to Carla and to all of the ET College mentors who supported our students throughout the day. Thank you to your teachers for making sure that you guys were all here and participating and engaged. And you guys had some phenomenal designs and some phenomenal troubleshooting considering some people had no sun today. So I would say kudos to all involved today. Please don't forget to complete your exit tickets. Students, you have exit tickets, and teachers, you have exit tickets. And then, of course, it is on the screen. Thank you for sharing. We have our upcoming Space Day next week, and we also have our machine learning on December 19th. Tell your teachers to sign up. I know we had some students interested in space. They were talking about it, so hopefully your teacher signed you up. And if not, just let us know, and we'll sign you up for another event.
Yeah.
Thank you all. Have a phenomenal day, everybody.
Thanks, Monica. Thank you, Alex.